Hello guys, welcome to my YouTube channel Chemistry is Fun by NB. Today we are going to study about the chemical reactions and the chemical equations, how you can define a chemical equation and how can you write a chemical equation, what are the substances called that are involved in the chemical reaction. So let's begin today's lecture. Okay, the very first thing is you must know about a chemical reaction, that what it is actually. So it is the process by which a chemical reaction or a chemical change takes place. And a change where a new substance is always formed is called a chemical reaction. So anything that involves a chemical change to form a new chemical is called as the chemical reaction. While the chemical equation is actually the symbolic representation of a chemical reaction in simple words. So if you are going to express any chemical reaction using the symbols, the formulas of the compounds and the numbers or the numerical values involved is called the chemical equation. Generally there are two parts of the reactant equation. The reaction usually involves two sides. One of the side which is on the left represents the reactants which are reacting in a reaction, and the right side contains the products which is formed as a reaction. Now you can see the difference between the two. Like the reactants, they are the starting materials through which the reaction starts, while the products are the new substances that are formed during a chemical reaction. Reactants are the substances that usually involve the changes when they are combined together or they are actually reacting in a chemical reaction, while the products are the results or the outcomes of the reactions that are formed after the mixing of special reactants. So this is the general representation. Reactants are usually written on the left side and products are written usually on reactants are written on the left side while the products are written on the right side. Now the coefficient and the subscripts. Coefficients are usually the numerical values or the numbers that are written usually before the symbols or the formula of any chemical or a reactant, while the subscripts are the numerical values or the number of atoms of the element which are found in the substance. So subscripts are usually written below the actual scripts lines you can see in the reactions. Now there are generally some symbols which are used in the chemical equation, like plus or the sign of addition. It is used to separate the different reactants and the products, and you can also show that they can be describing the mixing of the reactants, like something when it reacts with the other one, so you will add a sign of plus. Arrow. A single-headed arrow is usually written in the chemical reactions, which is used to separate the reactants from the products, and it is usually read as the following reactant produces, gives, or yields the equation. So that's how you are going to read it. Now the symbol S with the small brackets, it indicates the substance or anything reactant or product whenever it is present in solid state. So S is usually used for solid state. Small l, it is used to represent the substances in the liquid state. Small g, it is used to indicate the gaseous state of the substances. AQ refers to the aqueous state of anything if the substance is being dissolved in water, so we represent it usually by AQ. Then we have a symbol of delta sign. Delta, or a triangle, when it is placed above an arrow, it shows that heat is being involved in the reaction or heat is being applied for the reaction. So whenever you are going to increase the temperature or it requires temperature, you can call it as a delta sign. Now let's see the example. For example, we have a word equation. This is usually involved in the exams. Word equation is being written and you have to answer the equation in symbolic form. So sodium plus water, which is a very famous reaction, and it results in the formation of sodium hydroxide and hydrogen gas. So this reaction is very famous and it's quite explosive, and my students know very well that sodium usually can't be mixed with water because it is a very violent reaction until and unless you are doing it for some research purpose. So now we are going to write this word equation in the form of symbolic representation. So the symbol of sodium is Na, so I write Na. It is in solid state, so I write a small s plus water molecule, so I write H2O, and in the subscript I write small l, which shows that water is liquid. Sodium hydroxide is being produced as a product, so I write S in the solid state, and hydrogen gas shows small g has to be written. Now to separate the reactants from the products, I use the sign of an arrow with a single arrowhead. Now these are the reactants which are written on the left side, sodium and water. These are the products which are written on the right side. So these are the physical state symbols, and this number which is written in the start, it is used to balance the equation, and it shows the number of moles that are involved in this reaction. It is represented by the help of a coefficient. So this equation shows that if I have 1 mole of sodium, then I must require 2 moles of water molecules to form 1 mole of sodium hydroxide and 1 mole of hydrogen gas. We'll see how can we balance the chemical equation in our further topics. Now your task is to write or balance these equations. As you can see, magnesium solid state reacts with the chlorine gas to form magnesium chloride in solid form, which is a salt, just as sodium chloride is a salt. In the same way, solid carbon reacts with solid oxygen, and when heat is applied, it results in the production of CO2 along with the release of energy. So the rest of the equation you can also try it at home and practice by yourself. Now comes the balancing of chemical equation. To balance the chemical equation, the law should be kept in mind, which is the law of conservation of mass, that says that the sum of the masses of the products must be equal to the sum of the masses of the reactants. So actually, the statement refers to the mass which is neither created nor destroyed in any chemical reaction. So the first point shows that it should be equal on both sides, the number of moles. So we see the steps that are being followed for the chemical reaction. First of all, you are going to check out for the diatomic molecules that we have studied earlier. Di refers to 2 and atomic refers to atoms. So diatomic molecules are the molecules that contains 2 atoms. They can be similar or they can be similar or they can be different, but mostly they are similar. For example, this one H2 is a diatomic, O2 2 atoms of oxygen diatomic, N2 Cl2 and halogens, etc. Now look over here, the periodic table. The first group 1A, they are all are monoatomic, so only a single symbol is used. Group 2 is also monoatomic, but the halogen, this group 7A, they are all diatomic molecules. So now let's see how can we balance the equation. First of all, you are going to check whether the chemical formula that is written for the reactants and the products, either they are correct or not. Then we will check the total number of the atoms of each element on both sides of the equation. So left side must be equal to the right side, and if a polyatomic ion is being written, then it can't be changed on the other side of the equation, and the elements should be balanced one by one by multiplying the coefficients. But keep this in mind, the subscripts, they can't be changed, only the coefficients can be changed to balance. Now we'll check out for the atoms, either they are balanced on both sides or not. For example, if we had a container containing the hydrogen gas and that gas has been burned, resulting in the production of 2 gases, and that would be water in the liquid form to along with the release of energy to form the water. Now let's see how the equation is being written. We have H2 over here. It reacts with oxygen in the presence of heat to form water and the release of energy. Now we will go for step number 1, which is we have to count the number of atoms on each side of the equation. Now according to this equation that I have shown you earlier, there are two hydrogen atoms on the reactants and two on the products. Let me get back. See, there are two hydrogen atoms here and two here. So I write two on both sides. Oxygen. Two atoms are written here and one atom is written here. So reactant contains two and product contain one. So the first one is equal, but the second oxygen number is not equal. So we have to pick an element which we need to balance. So there are generally two ways to balance the chemical equation. The simplest one, which is most commonly used, I'll explain it first. Like you can multiply this hydrogen by 2 and also multiply 2 here on the product side. Then this will become, these 2 will multiply by the coefficient 2 multiplied by the subscript 2 results in the answer 4, and this 2 coefficient is multiplied by this subscript also answers 4. Now why do we do this? Because oxygen atoms are 2 in number here and here only one oxygen atom. So I have multiplied 2 here, and after multiply by 2 now I get 2 oxygen atom on both sides. But by doing this I have also changed the number of hydrogen atom, because now this 2 is being multiplied by this subscript and it results in 4 hydrogen atoms. So I have to multiply this by 2 so that I can change it into 4. So that is how you can balance the equation. Now there is another way to balance this equation which I usually recommend my students to do, is the fraction method. Instead of multiplying this by 2, just simply multiply it by 1 by 2, because if you are going to multiply oxygen of the reactant with 1 by 2, 2 and 2 will get cancelled out and results only in one hydrogen atom on both sides. So that's another way. Now the next one is the reaction of nitrogen gas with hydrogen to form ammonia, and it's a very famous reaction usually involved in the Haber's process. Let's see. The nitrogen atom. In the reactants we have two nitrogen atoms, so I write 2. In the product we have only 1, so I write 1. So it is not equal. Hydrogen here are 2 and here 3 hydrogens are present, so it is also not equal. So we are going to balance both the sides. Now to balance this, the very first thing is to balance the hydrogen atoms on both sides by multiplying the suitable coefficients. For example, if I am going to multiply 3 over here in the reactants, this 3 gets multiplied by 2 and results in 6 atoms of hydrogen. Now what should I write here to make this NH3 equals to 2? I have to write 2 here. Now the whole equation is being balanced. Now I'm going to explain this again in another way. Here I have 2 nitrogen atom and here I have 1 hydrogen atom, so I multiplied 2 with this nitrogen. Now I have 2 nitrogen atom here and 2 nitrogen atom here. But while doing this, I have also changed the number of hydrogen atoms. Now this 3 is being multiplied by this coefficient, and 2 into 3 results in 6 hydrogen atoms. So to balance this hydrogen with this H2, I have to multiply a number here so that I get the answer of 6 when it gets multiplied by 2. And I know that 3 is the only number. When it is multiplied with 2, it results in 6 hydrogen atoms. So now hydrogen and nitrogen both are balanced. Next is the reaction of zinc with hydrochloric acid. Again, The reaction shows the reaction of metal with an acid to form zinc chloride, which is a salt, along with the evolution of hydrogen gas. You can see zinc one atom here. Here also we have one atom of zinc, but Cl is one here, and there are two chlorine atoms, two hydrogen atom here and one hydrogen atom here. So simply I will multiply 2 here to make two hydrogen atoms here and here, and automatically chlorine also becomes 2 because this coefficient is multiplied by this whole HCl. So it results in the formation of two hydrogen atom, two chlorine atom, and in the same way two chlorine and two hydrogen atom. Now remember the key words and the key concepts, the reaction equation and the conservation of mass. Now this is for your task. You have to solve this exercise. You have to see the diagram which is given. What is happening in this diagram? Some of the reactants are already mentioned, like you can see sunlight is coming here, it is falling on the leaves, and in the leaves the carbon dioxide and water, they are being added, and here we get carbohydrates and oxygen. So this part is the reactant part and this part is the product one. So your task is to express this diagram in the form of chemical equation. Now this is usually seen in your houses. The stove, when you are going to on your stove and light a matchstick, when it comes near, it burns. Now you have to describe this picture, what reaction is being carried out here, which results in the burning of the gas or the ignition of your stove. Now this is another one. This reaction shows the diagram, which is actually the rusting of iron. Now this is a rod which is made up of iron, and over here it is damaged. Oxygen is being entered, and this portion shows the moisture content or the water drops, and it results in the formation of the rust. And this is the formula of rust: Fe2O3.xH2O. These are the ferrosigns, Fe plus 2 ions. Now you have to describe this reaction or this picture in the form of a chemical equation. These are the answers. When you are going to describe the pictures in chemical equation form, you can counter check this from these equations, either you are right or not. So that's the actual assignment. So what you are going to do, you just have to take a sheet and answer these questions along with a picture description. You are also going to answer the types of the chemical reaction and 3 examples of each type of the reaction. So that's it for today. I hope you have understood the chemical equations, their symbols, and how you are going to balance the chemical equation. So keep watching my channel and do subscribe to get the latest update. That's it for today. Thank you very much.